quantum entangle experiment performed on this satellite showed that shared quantum states can extend over 1,200 kilometers, smashing the previous world record. Quantum entanglement is physics at its strangest. Subatomic particles like photons can be entangled by sharing their quantum states, such as their spin and polarization. Even if the photons are separated by vast distances, these shared states should remain in limbo until one of the objects is measured or disturbed. Then the quantum states for both photons suddenly collapse to a set value, with no information passing between the two. With fiber optics, scientists have been able to demonstrate quantum entanglement on Earth across a few hundred kilometers. Any farther out, and the photon's quantum states are upset by fluctuations in the atmosphere. But photons travel much more smoothly in the near vacuum of space. That's where the MICEUS, the first space-based quantum research platform, comes in. Inside MICEUS, an ultraviolet laser is split and sent into a special crystal that produces entangled photons with opposite polarization states. The pairs are then beamed down to Earth, 5.9 million entangled pairs per second. 2 ground stations in China, over 1,200 kilometers apart, receive the photons. When the scientists measured the states of the incoming photons, they were correlated far more often than would be expected by random chance. Evidence that the photons had remained entangled across large distances. Although the transmission of the entangled photons was much more efficient than ground-based experiments, still just 1 in 6 million photons made it to the base stations. Next, the researchers plan to distribute quantum keys to the stations, which requires long strings of entangled photons. With entangled encryption keys, 2 people in separate locations could communicate secretly with each other, and any attempt at eavesdropping would be noticed. Researchers plan to extend the reach of the fledgling quantum network by adding more satellites and ground stations. That would be a stepping stone to a space-based, worldwide quantum internet.